Okay, guys, sorry that I could not be with you today, but we'll get rocking and rolling with some video notes. So, this might be your first time doing video notes, but we are going to watch a video, take notes as I'm going through them. If you ever need the video paused because you're falling behind or don't understand something, just raise your hand and let you get caught up. And once we get through the video notes, you can start working on exit slip and homework if you've got it. So you're going to go into Canvas. Hopefully, maybe you've already moved your notes over into Notability. If not, do so right now. We're going to start Chapter 8 today. We're actually going to do both 8.1 and 8.2 today. They're pretty short lessons, and I think we can get them both done in one period. So move those over. You'll see when you get into 8.1 that there is no launch. We're going to jump right in. And Chapter 8 is all about statistics, surveys, and data. Lots of other things too. Today we're going to take a look at certain samples and certain populations, determine if they're valid or not for a variety of reasons. We go down in here into slide 2, and it says a population is an entire group of people. A sample is a part of a population. You can gain information about a population by examining samples of a population. Now we've got unbiased samples, which are good. They represent the population. They are selected, this is important, at random, and it is selected at random, and it is large enough to provide accurate data. So you can't just survey 2 people, right? You're going to want to survey, 20, 30 people. The other thing is that it's got to be done at random. Okay, more on that in a little bit. I'll explain what that means. A biased sample is no good. It's not representative of a population. One or more parts of the population are favored over others. Again, more on that in a second. Unbiased is good. Biased, bad. Let's go down and identify unbiased and biased. Okay, so you want to estimate the number of students in a high school who ride the bus to school. Which sample is unbiased? Okay, so 4 students in the hallway. That seems pretty random, right? You're just grabbing kids, but like if you're in the 8th grade hallway, then you're only surveying 8th graders, so that's a problem. It depends on what time of day if these are going to be 4 totally random students, but we would say that's pretty random, right? 4 students during a class change, but the problem is this is too small, right? What if you've got, just by luck of the draw, 4 students who don't ride the bus? Then you're going to think, oh, nobody in this school rides the bus if these 4 don't. It's just too small. We need to survey more people, so it's not A. B, all students on the soccer team. Okay? This is not random. It might be big enough. A soccer team is probably 20, 30 kids. But you've chosen, you need to randomly pick kids. You've chosen a team of kids. They might have something in common. It might be all boys. It might be all 7th graders. You haven't really this would be a high school, so sophomores. 50 12th grade students at random. This is only 12th graders, so it's also not random. 12th graders, seniors, are not going to ride the bus much, right? They're going to probably drive more. They've all got their driver's license. So D, 100 students at random during lunch. It's big enough. Sample, check, and it's random. Now, you might be saying, well, what if the lunch is only senior lunch? I'm pretty sure at most high schools, lunch is a mixture of kids freshmen up through senior. We'll assume that here as well. All right, so that's going to be our unbiased sample. Unbiased. Let's go ahead and take a look at these triads. I think we're going to do the same thing we usually do for triads. We're going to pause the video, have you write down some ideas you have, and then I'll go over the answers. So go ahead and pause the video and press play when you're ready. Okay, so the first try it says you want to estimate the number of 12th grade students in a high school who ride the bus. Which sample would be unbiased? Well, then you'd want to do choice C, because you wouldn't want to be surveying sophomores or freshmen. You only want to be surveying seniors or 12th graders, and that was back here 50 12th grade students, and it would be big enough as well. Number 2 says you want to estimate the number of 8th grade students in your school who find it relaxing to listen to music. You consider 2 samples. 15, it's kind of small. Randomly selected members of the band, and you're just doing the band. Of course, those kids might be more drawn to music, so this isn't going to be. This is going to be very biased. It's kind of small, and it's not random. Every fifth student whose name appears on the alphabetical list of 8th grade students. This is a really good way to get a random sample. Like, just get an alphabetical list and do every 5th student. Probably going to be a big list, so you're going to be picking lots of kids. This is unbiased, large enough, and randomly chosen. This is too small. The band is not random. They're going to be biased. They're going to want to listen to music probably. Okay, we're on to example 2. The results of an unbiased sample are proportional to the results of a population. So if we've got a really good sample, we can use a proportion and predict what the whole population would do. Okay, so you can use the unbiased samples to make conclusions about the population. Biased samples are not representative of a population, so you should not use them to make conclusions about a population. You want to know how the residents of your town feel about adding a new landfill. Ooh, that stinks. No pun intended. Determine whether each conclusion is valid. You survey 100 residents who live closest to the new landfill. Well, let's stop right there. This is going to be this is going to be very biased. All these people that are going to live by this landfill are going to not want it. Right? They're going to say, we don't want to live by a landfill. But if you talk to somebody on the other side of town, they might be more willing to say, yeah, we kind of need a landfill. Maybe it'll bring in jobs. The diagram shows the results. You conclude that 10% of the residents of your town support the new landfill. Sample is not, write this word down, representative of the town because residents who live close will be unlikely to support the landfill. Something like this. I could probably have worded that a little bit better, but you get the idea. You'd have to go pick random, one person from every street in the whole town. You can't just pick the people that are going to be by the new landfill. It's going to be this is going to be very biased. Okay, so now part B, we're going to survey 100 residents at random. Good, 100's a big number. Some of you might be asking yourself, like, well, what's too small? It depends on the size of the actual population. So, for example, if you were surveying, this class period, second period, a pretty good sample is probably going to be somewhere between 5 and 10 students. It doesn't have to be that big. If you're going to if you want to survey Jones Middle School, well, you're going to need a bigger sample than just 5 to 10 because there's more kids. So it's hard to say what's a good size. For a town, 100 residents is pretty good. The table shows, and it's at random, table shows the result. You conclude that 60% of the residents of your town do not support the new landfill. We would say sample is unbiased So conclusion is representative or valid. Okay, so we could probably trust this data pretty well. Okay, let's see. Let's go ahead and pause the video and do the try it and press play when you're ready to go over it. Okay, so on number 3, we would say no, because the sample is biased. You only asked teenagers. Teenagers aren't going to represent the entire town, right? Like, you got to ask a variety of ages, because a senior citizen might feel differently about a landfill than a teenager might. I don't know why. But you want to get a couple people from each age bracket, a couple males, couple females, couple people in different types of areas, all that stuff. So we would say no. And I would probably also say that it's not large enough, because there's only 4 out of 5 randomly chosen teenagers. 5 teenagers is not going to be big enough. We're on to example 3 down here. 75 randomly chosen students at a school. Okay, that seems big enough. We're going to pause about this. We're going to stay positive, break it down part by part. Okay, I already stopped after, not even through the first sentence, and I'm thinking through what this problem might be asking. So let's see, you ask 75 randomly chosen students at a school how many movies they watch each week, okay? There are 1,200 students. Okay, it seems a little small, but I think we're going to roll with it. Estimate the number of students in the school who watch 1 movie each week. Okay, so we're going to say students who watch 1 movie is 21. And then we've got total students down here. That's going to be 75. And because we're going to say that this is a unbiased sample, we're going to say we can just use the power of proportions and say, okay, this goes in, 16 times. And I just did that because I know and I have the answer key in front of me. We could easily take 1,200 divided by 75, and we see it's times 16. So because it's an unbiased sample, we can treat it like a proportion and say about 336 students in the school watch 1 movie a week. That would be called our solution sentence. Now, we don't know for sure. That's why I said about. Okay, and you can see down here, you could have just set up a proportion to where you cross multiply. And essentially, that's what I did with my little table. All right, let's pause the video and you guys go ahead and do number 6 and press play when you're ready to go. Okay, so I'm not going to go over how to do this for time. I'm just going to tell you the answer, and then maybe if you guys have questions, we can talk about it when we get back. Do you think that this was, can you use this sample? Yes, the answer key says you can use the sample. It's big enough, and it's random. And let's see. We would estimate 6.2 megabytes. Again, not going to go over how we solved that one. If you got it, great. If not, maybe put a star next to it and remind yourselves to ask me a question about it when I get back. Section 8.2, guys, we're going to roll right into it because, the notes are pretty short today, so stay with me today. You have used unbiased samples to make conclusions about populations. Different samples often give slightly different conclusions due to variability in sample data, okay? So we might be looking at some different samples here. Yep, multiple random samples right there. It says, you and a group of friends want to know how many students in your school prefer pop music. There are 840 students in a school. Okay, it's quite a bit. Each person in the group randomly surveys 20 students. Is a bit small, but we're going to go with it. The table shows the results. Okay, so this is your survey, your sample, excuse me. This is your friend's sample, another friend's sample, another friend's sample, another friend's sample. Okay, use each sample to make an estimate for the number of students in your school who prefer pop music. Okay, so what we need to do in this situation is, for you, it was 13, and then what we have to do is add all of these up, 5 and 7, and you get 13 out of 22, and we can turn that into about 59%. We actually don't need to write it as a percent. Prefer pop music. So this is pop and this is total. Okay. What we could just do for you, and we'll do it in blue, is 13, out of 22 equals X out of 840. Cross multiply in our calculator, 13 times 840. Take that answer and divide by 22. And we get about 400. Oh, let's see. That shouldn't be right. Let's see what I do wrong. There are 840 students in the mid. I added up wrong. 13, 15. Oh, I added it up wrong. It's just 20 total in this sample. I bet a couple of you caught that. You're pretty good at catching my mistakes for me. Lucky for me, I have an answer key. 840. Okay, same answer. But now we're going to divide it by 20. There we go. 546 is what it was supposed to be. Okay, so that's how they got 546. Same idea. So now we're going to go ahead and do that for the rest of these samples. So I'm going to change up my color and say this one is 8. Out of, let's see, 11 plus 7 is 18. So maybe these are all out of 20. Yep, looks like they are. 8 out of 20 equals X out of 840. Why don't you guys pause the video, actually, and crank these out without me, and we'll see if you can get them right. Press play when you're ready to go. Okay, so I'm just going to fill these in using the answer key. You should have got 336, 420, friend B, 420, friend C, and 378, friend D. Okay, so we've got, I would say, quite a bit of what we would call variability, right? You all surveyed, you all asked about music, you've got random samples, but man, the results came out quite varied. You would say 546 kids prefer pop music, but you got this friend right here who would say it's only 336. And that's a difference of 210 kids. That's quite a lot. So what do statisticians do in this situation? Is they're gonna like take the average or take the median. They're gonna take these 5 samples and analyze them a little bit. So what it says down here is describe the center. I'm going to underline that and write mean or median, and you should have learned this last year. And then variation, which is I want you to do this in spread, means how spread out they are. We would say range or the MAD. The range or the MAD. Now, you might not remember what these things are. You should have learned them last year. I'll go over them briefly today and spend more time on them next class for sure. So we've got these 3 numbers. The mean, we're going to add them all up. then divide by how many we have, and that's going to give us our average. The mean is also the average. 378, we get 2100, and then we take that number, we divide by how many numbers we have, which is 5. There's 5 samples. Oops. 100 divided by 5. And I get 420. So on average, students prefer pop. Okay, we've also got, so this is my mean. I'll put that in parentheses. We also need to find the median. The mean is the mean one, but some kids say the median's tough too. Okay, so we would order these from least to greatest. So we got 336, 378, 420, 420, and 546. In this situation, the median, in all situations, is the middle. And in this situation, the middle number, you got to put them in order least to greatest. Don't forget that, is also 420. This doesn't occur all the time, that the mean and the median are the same. But in this case, it does. Okay, it's our middle number. Now, sometimes, though, we can also want to look at how spread out the numbers are, because then they're not as reliable. If we're getting numbers all over the place, we might say, ooh, we need to collect some more data because we can't really trust these numbers because they're so varied. There's so much variation or spread. Range is the max minus the min. Hopefully you remember that. So our max number is 546 and our min number is 336. So we've got a range of 210 students. Quite spread out, right? Like our samples are very different from each other. So we may want to scrap this and do a different survey, like do it differently because we got a pretty big range of students. We're also going to do the MAD, and that's the mean absolute deviation. How far are the numbers from the average? Now, lucky for you, we're not going to do it by hand today. I want you to open up your Desmos calculator and find the FUNC tab. That stands for function. Click on that, and you'll see all these stuff that you've never learned before. Let's see, maybe I have to do split screen because it should come up in function. That's interesting. All right, I lied. We got to use the graphing calculator, okay? You've never used the graphing calculator before. Move that over. Hopefully you've got that. If not, just watch. It's no big deal because the MAD is not going to be on your homework tonight. So what you would do is you would do the same thing. You would hit functions right here. And then you would go to MAD. So it was, I'll show you again. Scroll down to statistics. There's all kinds of cool statistics. The MAD's right there. And then I think you can type this. There's two ways you can do it. I think we can just go 336, comma 378, comma 420, comma 420, then comma 546. Yeah. So you can just put in the list. And so these numbers on average are 50.4 from the mean. More on that later, what that means, how to calculate that. I don't want to spend too much time on it today. Again, it's not on your homework. I really want you to understand that range, though. Okay. So use each sample to make an estimate for the number of students in your school who prefer rap music. I do want you to press pause and do the same thing, but for this here, rap music, and then press play when you're ready to go. Hopefully we have enough time to do this. Okay, so try it number 1. Again, I'm just going to go through the answers real quick. Wait, hold on, let me find that answer. Sorry, guys, I wasn't ready to go. Here we go. So it says the median should have been 42 students. For whatever reason, it does not list the mean on this. The range is 84 students. Now, we're not really talking about what these numbers mean and how we can use them a ton right now, because we're going to do that in example 2. So example 2 is going to say you want to know the mean number of hours students with part-time jobs work each week. At each of the 6 schools, you randomly survey 10 students with part-time jobs. Your results are shown. Use each sample to make an estimate for the mean number of hours students with part-time jobs work each week. Describe the variation of the estimates. All right, so I'm just going to fill this in real quick. We're actually not going to do a ton of math because it's going to take a while to crunch all these numbers. So here we've got these all add up to 70. These all add up to 73. These all add up to 77. So these are the hours that kids work. So a bunch of different samples that you would have taken. Just going around talking to 10 kids at random. And you see it's pretty varied based on those 10 kids. Older kids maybe are working more. Who knows? But each time you sampled 10 kids. So 70 total hours divided by 10 kids is 7. We do all these samples, we take our averages of the samples, and then we can take our average of our average, or we can take the median of our average. In most cases, statisticians actually like to use the median because there's these things called outliers. So let's just stick with the median in this case. So we took our average. Now let's put them in order, least to greatest. 7, 7.3, 7.7, 8, and 9. And we would say that, the measure of center is 7.3. They have a range. So let's see, median. Range is 9 minus 5, which is 4 hours. So we could say that, hey, we think that kids work about 7.3 hours a week, but we could also say give or take 4 hours, right? Because we've got samples that show us, actually it's probably 2 hours both ways. We've got samples that show us that it could be higher, it could be lower. So let's just say use all 6 samples to make one estimate for the mean. Oh, they want you to find the mean of all that, add all that up. Yeah, it works out to be the same thing, 7.3 repeating. All right, so I think we're getting a little long here. That's a lot of notes to take. I think we can wrap this up and review this when I get back. We were going to do example 3, and maybe we can pick up with that next lesson. You've got enough information to get through your homework, I think, for sure. If there's any questions on homework, just star them, do your best, and ask them when I get back. All right, we'll see you next time.